At first, this might look like it's going to be way different from the other inequalities that you've solved before. But it's really not. The only thing that's making this a little challenging, I think, is that instead of being compared to 0 on one side, it's being compared to a fraction, right? If it were just a fraction less than or equal to 0, this would be a simple sign table and we'd be done. But this one is not simple because it's two fractions compared to each other, two rationals. So all we have to do to get it so it's compared to 0 on one side is subtract one of these things over. I'm going to use x if you don't mind, because I just get tired of writing. I mean, a little of these Greek weirdo things, phi's is one thing, but I don't really want to write this all day long. So I'm just going to turn this into x's. So x plus 4 and x minus 7 less than or equal to 0. So look what I did. I just moved one fraction to the other side using subtraction. And now this is all set up for me to do a sign table on it. I just need to get it back in factored form. This is way not factored. So we're just going to have to do a little work at it. Well, you remember what to do when you're adding rationals together, right? We need to multiply each of these things by a crazy 1 to get it to have the same denominator as the other. So there's the left one. And the right one is going to be multiplied by the denominator of the left. So that's an x plus 1 over an x plus 1. Right, not so bad. So now we just simplify this and we'll see what we get. I know what the denominator is. Made some quick progress there. That's x plus 7, x plus 1. The numerator is going to be a little more work. Let's see. I'm going to focus on just this part. Okay, that's going to be x squared minus 10x plus 21. And let's focus on the right part over here. That'll be, and remember, this is a minus sign. So it's minus whatever I get. It's going to be minus x squared. And let's see, 5x, I think. So that's going to be minus 5x and minus 4. Okay, great. Now we can keep on moving. I'm going to simplify this by combining all like terms. So notice the x squareds cancel out. And then I have negative 10x minus 5x. So that's negative 15x. 21 minus 4 is 17. All over x minus 7 and x plus 1. Okay, so now I have simplified what I started with into a rational which has all linear factors. In other words, there's no x squareds, and it's compared to 0 on the other side. So we're ready for a sign table. So let's list our factors. One of them is kind of beefy, negative 15x plus 17. The other two are nice, x minus 7, x plus 1. And let's put our intercepts on here. So be careful with this part. You want to get them in the right order, otherwise things get kind of screwy. Negative 1 is clearly the smallest x-intercept. And then the next biggest intercept, well, it'll be this fraction. I do know that 7 is the biggest x-intercept. The one in the middle is going to be, if you go through the math, it's going to be 17/15. Right? We set this equal to 0. We solve for x. We get 17/15. Okay, great. So now we fill in our plus signs and our minus signs. Here's the x plus 1. Here's the x minus 7. And here's the screwy one, the negative 15x plus 17. Okay, so now you run down with multiplication and you figure out what the total is. 3 negatives makes a negative, 2 negatives makes a positive, 1 negative makes a negative, 3 positives makes a positive. And what did we want with this? Well, we wanted less than or equal to 0. So find the places where it's negative or equal to 0. It's going to be right here. And or equal to 0 means we're including these x-intercepts. Okay, everything looks great except one last thing. These aren't all x-intercepts. Some of them are vertical asymptotes. These are domain restrictions. You can't have an x value at that place because it's a domain restriction. It's one of those vertical asymptotes. The function just doesn't exist there. So it's not equal to 0. It's equal to infinity or something. So these ones are actually no good. We can't have -1 or +7. So here's the result. You get negative infinity all the way to -1. And instead of being that square bracket like you might think, because it's a vertical asymptote, it is a curvy parentheses. And then the next place it's negative is at 17/15. Again, I'm using a curvy, whoops. Here I do need to use a square bracket because that is an actual x-intercept at 17/15. And that goes until 7, which is not an x-intercept. That's a vertical asymptote, so it's a parentheses. And that's all the negatives. So I have solved this inequality. I think the key here, compared to what we've done before, is knowing what to do when this is not 0. When that's not 0, you just have to do a little work and make it equal to 0 for the comparison with a simple factored rational on the other side.